Yes, hey Litcode fam, welcome back. And now let's solve the question. 513. Find bottom left tree value. And yeah, again the question is pretty straightforward. You will be given a tree and you have to tell the bottommost left value in the tree. For example, you consider this tree. 7 is the bottommost left value in the tree. And like whenever you see this problem, one thing should pop into your mind. I'll give you a few seconds to think what should pop. And yeah, I know this is like a classic YouTuber trope telling, oh yes, go and watch my previous video. Do like, share, subscribe, comment, and all. But yeah, I don't believe in that those kind of things. I believe that these kinds of videos should not have some prerequisites like go and watch all my previous videos to understand this video and all. But yeah, knowing one thing is extremely important, and that is level order traversal. And again, I have covered it. I have covered it. And if level order traversal did not pop into your mind as soon as you saw this problem, then you must obviously want to solve some level order traversal questions, because yeah, this is complete level order traversal code but with very small modification. Since they have given us to check for the leftmost node in the tree, what we have to do is after each iteration, rather than going like this from left to right, we will go right to left, and that way we will by the way how I have taken, it will be pretty clear that we will always be left with the leftmost value whenever we will be always left with leftmost value. So let me just go through the code once. So again, you have to be able to write this part of the code with your eyes closed. So yeah, leftmost, let is yeah, according to the constraint there will be at least one node, so there will be one leftmost value. So we can, there's no need to check if there's no tree, then we have to return or something. So we can directly set the leftmost to 0. And yeah, again this is like really classical level order reversal while queue exists. It's val over here. Be sure to check how the tree node is defined. And in normal level order traversal where we were going from left to right, what we did is if yeah, we did like this. If the left node existed, then go to the left node first. If right node existed, go to the right node. But what it is given to us is we have to find the leftmost node. And if we do like this, what will happen by the end is the leftmost will have the rightmost node. Yeah, if you consider 213, let me just print the leftmost value. Yeah, I think there's some indentation error. Let me just check, correct it once. Yes, let me just print the leftmost and return some garbage value. And yeah, so what will happen now is you will get the rightmost value. Yes, check it out, you got the rightmost value of this tree. And yeah, in this rightmost or leftmost does not matter because there is only one value at the last level. So wait, let us add another node to the last level. And yeah, in how what you tell lead code takes in the input is that we have to give the level order traversal again as an input. So if you put null and then 9, what will happen is it is a null and not null. Yeah, see, after 7 it took a null and then it took the 9. So now what will happen is we'll get 9 as the output. Yes, you got 9. And if you added one more node, like I don't know, after 9 if you added 100, yes, then see the tree is like this, so you'll get 100. So yes, you see that you're getting 100, but what we want is we don't want the rightmost value, but we want the leftmost value. So just swap this around. So now what will happen is after each iteration, first it will add this node, and then to add this node and this node. then it will pop this node, add its right and then its left, and then it will pop this node, there's no right, so it will add left, and then it will, yeah, and then it will pop this node, add its right, and then it will pop this node and add its right and left, but there are no children, and it will pop this node, add its child, left node, and actually that is the value which has to be written, because after this it will be none and none. So yes, now we can directly return the leftmost value, and yeah, this should theoretically work, but hey, oh yes, hypothetically it should have worked, and now we are seeing that it is working properly. Now let's just submit it, and yes, the code submitted, and yeah, it is like super efficient, and there is, and the only space required is a queue to keep track of the traversal and nothing else, and one more to keep track of the leftmost value. So yeah, this is like super efficient in terms of space and in terms of time. So yeah, thank you for watching. Good luck, grind more DSA, and let's go.